question. That's going to be your title. It's really 2 sentences, so I think you can manage. But our question today that we're starting with is a very similar to one that we started with on Friday, which is splitting cookies. Miss Miller and Miss Jennings are sharing 3 cookies equally. How much should each person get? Go ahead and write that down, please, as your title. All right, how are we going to solve this problem? Go ahead, Harper. What is your solution?
So you would get 1 whole cookie, Miss Jennings would get 1 whole cookie.
All right, so hang on. I'm going to have Miss Miller on this side. Go ahead and write if I'm writing, please. And I'm going to split it in half. And then here is Miss Jennings on this side. You probably already have 2 separate piles. We just want to label them. We got Miss Miller and Miss Jennings. Now Harper says, I'm going to get 1 whole cookie. And Miss Jennings is going to get 1 whole cookie. Does that make sense?
No.
There's 3 cookies.
There is 3 cookies. But would it make sense that I get 1 and Miss Jennings gets 1 whole one?
Yeah.
So we do still have that extra one though, Harper, right?
The extra one you'll break in half for you and Miss Jennings.
Okay, so I'm going to get a half a cookie. How did you draw that, Harper? Half a circle? Like this? Okay, and then for Miss Jennings, how much did she get? Half a circle. How would you write this in number form? How would you write that in number form? Your picture is exactly right. But how am I going to write that in number form? Will, what do you think?
Yeah.
I know, it's tricky. Michael, what are you thinking?
Like fraction.
So how would I write it?
Like the thing where you put like a number and then a line and then another number. I think it would be like 1 and then a line.
Let's start with the part that we do know. Do we know how to make this 1 whole cookie a number?
Yeah.
How do I make that a number?
1.
Good. Just 1. That becomes a number 1 because that's 1 whole. And I know I got 1 whole cookie. Now what about this half? How do I write that? How do I write that? What does that look like? What do you think, Sean?
You write 1 with a slash next to it, and then you write a 2.
Why did we write a 1, a slash, and then a 2?
Because the fraction that it means is 1/2.
That is what it means. What does that 1 inside that fraction mean?
It means the whole.
Doesn't mean the whole. I didn't get the whole thing, did I?
It means the half.
It means you're so close, Sean. Brayden?
The one is the 1 part.
It's 1 part. I got 1 part. My part was the half, but that 1 means I got 1 part of it because Miss Jennings got the other part. What do you think that 2 represents in that fraction? What do you think that 2 represents? Kenley? How many pieces made up that whole cookie? I only split it into 2 pieces. 1 for me and 1 for Miss Jennings. So I would write this as 1 and 1/2. Notice my digits are different sizes. Did you see that? 1 whole is bigger when I write it than 1/2. How would I write Miss Jennings' piece? So anyone give it a go?
Yeah, same way.
Same way. She had 1 whole plus 1/2. Notice I did my slash a little bit differently.
Yeah.
How you make your slash doesn't really matter. I'm a big fan of this way right here. I think that's easiest to see and it looks more like a fraction. But you will see if I have to type, sometimes my fractions end up with a diagonal slash. Sometimes the computer will make it look like a regular fraction, but not always. So if you see a slash horizontal or if you see it sideways, it's still going to be a fraction. When
Freckle, you're typing in the fractions, you have to put some.
Yep, and freckle, if you type in a fraction, it's got to be a slash. All right, so let's talk about a whole number versus a fraction. Just a second ago, we looked at a whole number and a fraction. Go ahead and make a subtitle, whole number. That's what we're going to talk about first. A whole number. That's your subtitle. It just goes underneath what we've been writing.
We write just one number.
Just whole number. If you want to write the whole question, you can, but I think whole number might be a little easier. A whole number is exactly what it sounds like. These are the numbers we say when we are counting. These are the numbers we say when counting. A whole number, if I write an example, 1. When I got one whole cookie, that is a whole number. Do you think of another whole number? Lincoln, you can think of a whole number? 2. 2 would be a whole number. I could get 2 whole things. That would work. Shelby? 5. That will work. That's a whole number. 7. 3. What about 100?
Yes.
Yes.
500 billion.
500 billion. Is that a whole number?
6.
No.
Yes. What about not whole numbers? Because we do have numbers that are not whole numbers. This is our not box. I want you to draw a knot and then put a box around it. We're going to put some numbers that are not whole numbers in there. What might be not a whole number? It's a little tricky. Bill, what are you thinking?
5.1.
Ooh, 5.1. So that's a decimal. And it's not going to be a whole number because I have a little bit extra. That's what that decimal means. So an example of not might be 5.1. That 0.1 means I don't have the whole thing. I have the whole plus a little bit extra. That is not a whole number. What do you think, Sean?
0.0.0.0.1.
So we're not going to have all those points, but I think what you're trying to tell me is another decimal. 0.0001. A very small amount. Sure. What about this number? Ready?
Yeah. A whole number. No.
Is it a whole number?
Don't count a number at all.
It is. It is a number. Let me clarify this. Let me clarify this. It is a number, but it is not a whole number because it's not a whole quantity. Negative. You can't have it. I can't hold -2 in my hand. You can't hold it. I can hold 2 things in my hand, which represents the number 2. Yes, I can. So you cannot, Gwen. Thank you. Will? 0. 0.
How did none of us think of that?
What about this number? Ready? Is 1/2 a whole number?
It's a half.
It's
No.
part?
No,
Is that half a number?
Yeah, I have one.
Not a whole number. All right, new subtitle.
Yeah?
Now we're going to talk about fraction. We know from our not box that it is not a whole number. It doesn't belong in the whole number category. However, what is a fraction? What is that talking about? We looked at some equal parts on Friday. We looked at a fraction today. What is a fraction? Lincoln, what is a fraction?
Like half a number or something?
Okay, so would a fraction be, How am I gonna write that, Lincoln? You're such on the right track. Can you say that one more time?
Like, it's half a number.
Okay, so we have half would be an example of a fraction. Sean, what is a fraction?
You could write if you had 4 people coming over for a party, and then there was one box of pizza. You had 1 box of pizza. You have to split it into 4 slices so everybody can get it equal amount.
Okay, so we've got a lot happening in that example. We know that fractions can share, and we know that fractions are sharing equally. On Friday, we looked at equal shares, equal cuts, and we know that being equal, having the same value, even if it looks different, is very, very important. It's very important. Fractions, kind of what Lincoln, I think, was trying to say, can represent parts of a whole. So if I have a whole number, like 1, but I don't quite have the whole thing, like in our cookie problem, Ms. Jennings and I had to split that last cookie and we ended up with just a half. That's not a whole cookie, but it's part of a whole. Fractions can show parts of a whole. Does that make sense so far? We got that written down? Okay. All right, we're going to read a story. All right, what are some things that you saw around my room that could represent or be represented as a fraction? Go ahead and turn to the next blank page. Your title is going to say, if you were a fraction. If I were a fraction. In Miss Miller's room. Alright, what were some things that you saw that could be fractions? Will, what was one thing that you saw?
Window, it's 1/2.
The window. Alright, so let's draw a box. How many sections are in that window, Will?
2.
How many window panes, the different sections are there?
4.
Let's look at that window again. There are 8. I know some of them have blinds, which makes that a little complicated. So there's one bar going all the way across. We have 8 different windows. The window is split into fractions. One way we know is we have the whole window and it's partitioned or split up into smaller sections. Also, all those sections are the same value. How would I write a fraction to show one window pane? What is this one window pane worth as a fraction? Shelby? 1/8. Have you noticed with fractions you kind of say them a little funny?
1/8.
So I don't say 1/8, I say 1/8. There's a TH on the end. 1/8 split into 9. 1/8. What do you think this window pane is worth right here?
1/8.
What about that one?
1/8.
What about that one?
1/8.
1/8.
Every single window pane on its own is going to be worth 1/8.
How do you change her?
We'll talk about that in a second. Right now we just want to look at where some fractions are. Page and have to look out. What were some other examples of fractions that we saw? Will saw the window, and I think a lot of you saw that. Brayden?
That shelf right there.
The shelf where our whiteboards and crayons and extra copies. So I have my whole big shelf, Brayden, and how many different parts is it partitioned into? 6. Very good. partitioned it into 6. That means one shelf, Brayden, is going to be worth how much? 1/6. It's only 1/6 of the whole thing. Well, then what about this shelf? What is it going to be worth?
It's going to be worth 1/6.
1/6. What about this shelf, Devin? 1/6. Do you know why or how I know they're all going to be 1/6?
Because it's
All the
they're all
same.
the same.
They're all the same value. They're all the same shape, and
They're all a part of 6 squares.
they're all a part of my same whole. Very good. Michael,
I don't know.
okay, give me one.
The
Globe. Ooh. How is the globe partitioned?
it's split in the middle.
It is. Love that. Give me a Me Too signal if you also thought of the globe. I never thought of the globe. That's interesting.
Yeah, I thought it would.
We talked about that Friday with hemispheres. The equator splits our globe in half. Awesome. Awesome. Bella, what would this section of the globe be worth? 1/2. It wouldn't. I wish we would say 1/2. That would follow the rest of the pattern, but we use the word 1/2. Ashley, did you find another fraction? My cabinets. Ooh. Now let's look at the bottom cabinets versus the top cabinets. I'm noticing something interesting between the bottom cabinets and the top cabinets. What are you noticing? Ashley, what do you notice? Yeah, so we've got some different size cabinets. That doesn't mean that we can't use fractions still, but for right now, let's just look at the lower cabinets, okay? So I've got my lower cabinets, which are already the same size. Ashlyn, how many doors do I have? I have 6. 1, 2, 3, 4, 5, 6. I've got my 6 doors or 3 cabinets. So let's think about that, Gwen. Gwen said there's only 3 cabinets. If I redraw underneath the same lower cabinets, but instead of drawing the doors, I draw the actual cabinet, the box. So if I think about it like Ashlyn, and I say, okay, there's 6 doors, what is each door gonna be worth? Kenley? 1/6, very good. But if I look at those cabinets and I think about it like Gwen, and I think about it in terms of actual cabinets, what are those cabinets worth, Will?
1/3.
1/3, very good. 7?
Could this still equal the same I did?
What do you mean by that?
I mean, so she did it a different way than
So Ashlyn did the
Ashlyn.
top one and then Gwen did the
Are they
bottom.
still equal this?
They do still equal the same. So let's look at this. Each cabinet, right, if here's my cabinet, has 2 drawers. Do you see that?
Yeah.
So that tells me that 2 1/6 plus another 1/6, 2 1/6 pieces is worth the same amount
As 1/3.
as 1/3. You see they take up the same amount of space.
Yeah.
Interesting. Interesting. Shelby?
The word reading.
Reading. Okay, what do you mean by that?
The calendar is 7 letters.
Okay. So each letter is what?
1/7.
1/7. Very good. Got that. Sean?
I did the notebook.
The notebook.
Unfortunately, it has one line down the middle.
Ooh, is that going to be a fraction?
Yes, it has.
Is it?
Yeah.
Is it a half?
No, because of the B. Yes, it's a fraction.
Which line are we talking about, Sean? That might be helpful.
Oh yeah, there's the line that when you close it, it's like
The crease. So I thought, Sean, you were talking about just one page and this red line.
no,
Would that red line
No.
just be a half?
no.
Well, I have one line and I have two sections. That sounds like a half.
But they're not equal.
That's not equal. It's not gonna work. But Sean was actually talking about, if you look at the whole notebook, the crease. Now is the crease one half?
Yes.
Yeah. Yeah. All right, I have one last. Will, what's up?
Oh, I don't know.
Go for it. So we're going to talk about counting fractions. You can count fractions just like you count regular numbers. So regular counting, let's pretend I am counting books. I might say, thank you, one book. Then I would say, oh, now I have two books. Then I would say three books. A lot of the times when you become good at counting, which obviously you guys are now, you're third graders, you don't say one book, two books, three books. You just say 1, 2, 3. There are 3 books. But you know in your head, you're counting books. You don't just say one book and then 2 pencils. That wouldn't make sense. You count each book as you're counting. We already know how to do regular counting. We're pretty good at it. That's how we got to third grade. So let's talk about fractions. Do you have a question, Lincoln? Can you wait till I'm done? Thanks. If I'm counting fractions, it's going to be very similar. I'm going to split this fraction into 4 pieces. Yes, if I'm writing, you are writing. The first piece is pretty simple. We know what that first piece is going to be called. What would I call this first box? 1 what? Bella? 1/4. Now, if I wanted to know about 2 pieces, I would say 1/4. Oops, I wrote 1/2. 1/4. 2 1/4 pieces is equal to 2/4. If I have 3 1/4 pieces, guess what it's going to be? 3/4. So instead of counting my books like I would in regular counting, or pencils or glue sticks, I'm going to name what kind of fraction I'm counting with. If I'm counting halves, 1/2, 2 halves, 3 halves, 4 halves. If I'm counting fourths, 1/4, 2/4, 3/4, 4/4, 5/4. These 1 section pieces, this right here, that is called a unit fraction. A unit just means that's what you're counting by. So if I'm counting by halves, then my unit is halves. If I'm counting by tenths, my unit is tenths. So I would just say 1/10, 2/10, 3/10, 4/10. Red fish, blue fish. Those are my unit fractions. It just tells me what I'm counting by. Sean?
1
A 1-1. Do you know what we call it? A one hole. If I have one piece out of one piece, then I have the whole piece.
It's kind of like multiplication. If you do 1 times, if you do 1 times 1, it's 1.
Kind of. You'll find some similarities in there. All right, so what you're going to work on right now is we have Scott, who's recorded some objects with some different things around his house. He's got looks like a pizza, a window, and then a filing cabinet. So the first box is how many pizza slices are missing, how many broken windows, how many open doors. What would be the fraction to show that? Does that make sense? Go ahead and work on that, and I'll be around in just a second. The paper that's in your notebook. That's okay. That's right. So here's our pizza. How many slices are missing in that first pizza? Missing slices. Well,
1/8.
not 1/8 slices. I'm just missing one slice. I'm missing one slice. My fraction will, that's, I think you got ahead of it, that fraction is going to go in the next section. How many slices would make up the whole? If I had all those pieces, how many would I have? 7? If I had all of them. Look, you have it in front of you. If I had all the slices, let's say it just got delivered to my house, how many slices would be there? Sean?
8.
There would have been 8. So my whole is partitioned into 8. So I'm going to be counting 8 because I have 8 slices. But I'm missing 1. So my fraction of what I'm missing, 1/8. That makes a little bit more sense.
0/8.
You could do 0/8. If I have 0/8, how many do I have? Nothing, just like 0 groups. Right? All right, let's look at our next one. How many broken windows are there?
Little like broken window panes.
Broken window panes. Yes, let me be more specific. Bella? 1. What would be that fraction of the whole big window set?
1/6.
What would be that section? Nope. What would be the fraction of the whole set? Jackson? 1/6. Very good. Because I had 6 total pieces, and then one of them was broken. Harper, question? You got it? You got the last one? How many drawers are open, Harper?
1.
There's 1 drawer open. So the fraction of all the drawers that are open, Michael?
1/4.
1/4. We still have to look at all the drawers first. Does that make sense? So can you fix yours so that's written correctly? Because that's not written correctly. No,